For simplifying rational expressions, you really need to have an understanding of the rules of exponents or laws of exponents. So that sounds fancy, but it's really just a matter of saying, here's what you do with your exponents for these different operations. So when you are multiplying variables with the exponents, you add them. When you're dividing variables, you subtract the exponents. When you are taking your exponents to a power, and your exponents are when your exponents are powers, you multiply them. And when you have the power of a product, it's a to the x times b to that x. So you're distributing that x to your two variables. Same thing with the fraction. You are distributing that exponent to both the numerator and denominator, giving you something like this. And anything to the 0 power is always 1. And anything to a negative power is going to be 1 over the variable raised to that power. And finally, you might not see this yet, but this is a fractional exponent. It just means that it's taking it the root, the y root of the numerator. But like I said, you might not see this one just yet, but you will be dealing a lot with these top ones. So getting started, we'll go ahead and go over this problem that I have here as an example. We're going to start with the power outside of the parentheses, and we're going to distribute it. That's the power of the using the power of the fraction rule. We're going to distribute that a will be cubed, and b to the negative first power cubed is just b to the negative third power. And then we're going to take our denominator. 2 cubed is 8. A cubed to the third power, that's where we go here. And we look and see that since it's that raised to a power, we multiply the exponents. So you're multiplying the 3 and the 3. You get 9, so it will be a to the 9th. And same with b squared. You're going to multiply your exponents. Since you're raising the exponent to another power, 2 times 3 is 6. So now that we have distributed that power to all parts of the expression, you can go ahead and simplify it. Since there is no numerical coefficient in the numerator, that's known to be 1. That can just stay there for now, and we'll move on to our a's. When you have a fraction bar here, that kind of means you're dividing, so we're going to subtract. It's 3 minus 9, which would be negative 6, or we would keep the 6 in the denominator. I need to put that somewhere else. So, writing it down here, we're going to have an understood 1 in the numerator. Our 8 is in the denominator, and we just worked with our a's. We don't have an a cubed anymore up top because 3 minus 9 is to the negative 6th power. We can just write it as to the 6th power in the denominator. And then b to the negative 3rd power minus b to the 6th power. That would be b to the negative 9th power. And that sounds really confusing, but really if you look at the exponents and look at this bar, that's division. And you're going to come over here. That tells us, since it's a division problem, or you have that, you are subtracting your exponents. So you have negative 3 minus 6. And whenever you're working with negatives, that's like saying plus a negative 6. which equals negative 9. So that would give you b to the negative 9th power, but with rational expressions, it always looks nicer in an answer to keep your exponent positive. So what we're going to do for that is just keep that b down here, so you can have b to the 9th and you don't have anything that looks like b to the negative 9th. So in writing it this way, it looks nicer because we don't have any negative exponents, and this will be your final answer, this 1 over a to the 6th times b to the 9th. Another example we have, we're still going to use our rules of the exponent, so I'll just keep this up on this slide too. This one's a little easier because it doesn't have an exponent outside of parentheses that you have to distribute to every term. So really you can just go ahead and start simplifying, and I'm going to start with our numerical coefficients here. 75 divided by 5 is 15, but don't forget your negative sign. So that's going to give our numeral 15 on the top. So next we have 15a to the 5th b squared over a to the b and times b to the 6th. So now we can work with our a. This right here is known as a to the 1st power. So this is using our division rule again, where we subtract our exponents. So we're just going to do 5 minus 1, which will give us a to the 4th. So now we have 15 a to the 4th times b squared over b to the 6th. So we've really simplified everything out now except for these b's. And again, this is where we're going to use that division rule. You're treating this fraction bar as a division sign, so we are going to subtract the exponents. So you have 2 minus 6, which is like saying 2 plus negative 6, which gives us negative 4. We don't really want a negative exponent in our final answer or our simplified expression, so we can put that negative 4 as an over b to the 4th. We're going to put that in the denominator. So your final answer for this one will look like this. It will look like 15a to the 4th power over b to the 4th. And like I said, you could put the b to the 4th up here, but it would have to be b to the negative 4th. It looks nicer to keep your exponent positive and put it in the denominator. So that's why this is the final answer to that problem. And it cannot be simplified anymore.